So here's a few questions to practice algebraic expression, building our own algebraic expression from statements. Question number 1. Hammond and his family were going on a journey by bus. He bought 2 tickets for himself and his wife, and 6 tickets at half price for his children. Express in symbols the total amount he paid in terms of the price of tickets for all dots of the price of tickets for all dots. So before we go about writing the algebraic form for this question, let's just wrap our mind around it and see. Let's assume the price of ticket for all dots is 6 cedis. So price of ticket for all dots is 6 cedis. Let's just assume that. So that's the fixed price for tickets. So price for tickets is 6 cedis. And he bought one for himself and another one for his wife. So for himself and for his wife, that gives us 12 cedis. This is how much he paid for himself and his wife. Then he went ahead and bought 6 more tickets at half price for his children. So if he has 6 children, he bought 6 more tickets for them. So that would be each ticket is 6 cedis, right? So he bought 6 of them. One for 6 cedis. So 1, 2, 3, 4, 5, 6. So 6 more tickets. So if that's the case, 6, 5, 30. That should be how much he should pay for the 6 tickets. But interestingly, he bought the 6 tickets at half price for his children. So half of 30 is actually, I think this is 6. 1, 2, 3, 4, 5, 6. 6 is 36, not 30. 6 is 36. Good. So half of 36, that should give us 18 cedis. So this is how much he paid for the tickets for his children. So in total, he paid 12 plus 18, that is 30 cedis. Good. This is a straightforward one if we know the price of the ticket. But in this question, we do not know the price. So now let's go ahead and solve this question using symbols only. So remember this, we assume the price of the ticket is 6 cedis. That gives us the total amount he paid to be 30 cedis. But let's solve this using algebraic expression. So let's get back to the question. We are asked to express in symbols the total amount he paid in terms of the price of tickets for all dots. So let's assume this. Let's solve solution. So let's assume the price for a ticket for all dots is X. And then the total cost or the total amount he paid for the whole ticket to be Y. So let's write that out. Good. So the price for one ticket is X and the total cost he paid for all the tickets should be Y. You can use any alphabet of your choice. So now let's look at this. Hammond and his family. But he bought 2 tickets for himself and his wife. So tickets he bought for himself and his wife. So tickets he bought for himself and his wife will be X plus X. This for himself and this for his wife. So X plus X gives us 2X. Because that's the price for one ticket. They went ahead and bought 6 more tickets at half the price for his children. 6 more tickets. So 6 more tickets for his children. So let's write it this way. So 6 more tickets for his children will be X plus X plus X plus X. That means 6 of X or 6 times X. So we can just write 6X or X plus X plus X 6 times. So 6 more tickets for his children will be 6X. This is more like adding X to itself 6 times. So this is how much he paid for the 6 tickets for his children. But look at this. He bought 6 more tickets at half price for his children. If you remember building algebraic expression, half of something is the thing divided by 2. So the amount he paid for the tickets for his children will be half of what he paid. That will be half 6x, which gives us 3x, because these 2 will divide this 6, giving us 3. So this is how much he paid for his 6 children. Now we are asked to express in symbols the total amount he paid in terms of price of ticket for all dots. So total amount he paid is y. So total amount paid. Total amount paid will be equal to what he paid for himself and his wife, which is 2x, plus what he paid for his children, that is 3x. But look at this, total amount he paid is represented as y. So let's use symbols for that. So, comma, so that means y is equal to 2x plus 3x will give us 5x. So that's basically what we expected to do. Good. Now let's move to our next question. A certain number x is multiplied by 5. Another number that is 6 less than x is also multiplied by 5. By how much is the first product greater than the second? So that means we have 2 products. What is the first product? The first product is this, a certain number, which is x, is multiplied by 5. So let's get the first product. Solution. So the first product is 5x. So let me write it here, first product. The first product is 5x. Now another number that is 6 less than x is also multiplied by 5. Another number, but this number is 6 less than x. So that is the second product. So let's write it here. That second product is 6 less than x. That is x minus 6. But interestingly, this number, which is 6 less than x, is also multiplied by 5. So this number, which is 6 less than x, is multiplied by 5. So this is what we have. So if we actually expand on this, that will give us 5x minus 30. That is what we have. 5x minus 30. Now the final part of the question is asking us this. By how much is the first product greater than the second? By how much is the first product greater than the second? And what that means is that we have to take the first product and then subtract the second product from it. And what is the first product? The first product is 5x minus the second product. The second product is 5x minus 30. So let's work on this. 5x minus 5x. This is minus. It assumes there is 1 here. So negative 1 times positive 5. That should give us negative 5x. Negative 1 times negative 30. That should give us positive 30. Because negative times negative gives us positive. So let's look at this. Positive 5 minus 5 is 0. 5 minus 5. So we subtract the numbers. 5 minus 5 is 0. So it's more like this is taking care of this. So you're actually left with only 30. So by how much is the first product greater than the second? The first product is 30. It has 30 more values more than the second. So basically that's what it means. Let's see if we can actually prove this. That's one thing I love about maths. Let's see if we can actually prove it. Let's do it this way. Let's assume that our unknown value, which is x, is 10. Let's assume it is 10. So if it is 10, that means our first product to be 5 times 10. That gives us 50. And our second product will be this. This is our second product. 5 into bracket x minus 6. So 5 into bracket x minus 6, which is the same as 5x minus 30, which is the same as this. So because we expand on this, we get this. So 5x, but x is 10. So 5 times 10 minus 30. So 5 times 10 is 50 minus 30 gives us 20. Good. So that means the second value is 20 while the first value is 50. So now let's check this. By how much is the first product greater than the second? By how much is the first product greater than the second? Look at this. The first product is 50 and the second product is 20. 50 minus 20 is 30. It's the same as this. So we've been able to prove our answer to be correct. So that means we've actually gotten it right. Next question. Kobe is 8 years old. His sister's age is 5 years more than half his age. How old is his sister? So you can pause this video and then try figuring out what the sister's age will be and write it in the comment section. For this particular question, we are actually not going to get a figure. We are going to get an algebraic expression. So let's start it. Solution. Kobe is 8 years old. So Kobe's age. His sister's age is 5 years more than half his age. So half Kobe's age will be a divided by 2 because that's what half Kobe's age means. But his sister's age is 5 years more than half his age. So what would that be? So Kobe's sister's age, so let's write it this way. So his sister's age will be half of his age plus 5. So that's it. As simple as that. So how old is his sister? So Kobe's sister is 8 divided by 2 plus 5 years old. That's it. So this brings us to the end of the questions on building algebraic expressions. Our next video will be on operations on algebraic expressions. Operations on algebraic expressions. See you over there.